In this video, the connection between Netfabb and the Advanced Toolpath Utility, ATU, is explained. You will learn how to create an EBPA in ATU and use it in Netfabb. Though ATU is a special JavaScript development environment, no programming skills are required for this video. Let's have a look at toolpath calculation for a metal powder bed machine in Netfabb. Open the generic MPBF machine. MPBF stands for Metal Powder Bed Fusion. Maybe Netfabb offers a dedicated machine configuration for your metal powder bed machine. Open My Machines and check it out. Open the configuration editor and look through the available configurations. There are two types of configurations, Simple and EBPA. Select an EBPA configuration. A default configuration has to be duplicated in order to modify its parameters. A name can be set for the new configuration. Solid part is the name of the current parameter profile. More profiles can be defined if necessary. Parameter profiles can be assigned to individual build parts. The configuration offers several categories of parameters. Let's modify a parameter and see what it does. Entering a value of 2 here should make the hatch filling skip every second layer. The modified configuration is now set. Solid part is the current strategy. Let's start the toolpath visualization. The calculation may take some seconds. See the generated toolpaths in green. The hatch filling is skipping every second layer, so the modified build strategy has been used on this build part. The EBPA configuration provided toolpath parameters and it also calculated the toolpaths. An EBPA can also contain its own exporter to write the toolpaths into a file, which is then used to build the parts on an additive machine. Netfabb does not know the meaning of these EBPA parameters, nor does it know how to create toolpaths based on these parameters or how an EBPA-based file format looks like, because all this is managed by the EBPA. So an EBPA encapsulates much of the know-how which is required to run a certain additive machine. Now let's see how we can create our own EBPA. For this, open the Advanced Toolpath Utility, ATU. In ATU, create a new project. There are many project templates to choose from, containing example code for different topics. Filter the list using keywords. Select a template. Here it is, checkerboard hatching. A project name is required as well as a project path where the new project files will be created. The project name can also be used to create a subdirectory. So the new project will be created in a subdirectory and not in the given path directly. The new project would already be able to create toolpaths and other things like a visual smoke simulation, but for this an input geometry is required. There is a dialog element for managing input geometry files. Select a file from the part library. The triangle mesh from the 3MF file is automatically sliced so that slice contours are the input for toolpath calculation. By moving the vertical slider, the current layer can be changed. There is also a 3D view which shows the input data's whole layer stack. The current layer is highlighted in this view as well. If now the project is compiled for the first time, the generated toolpaths will become visible. As it was stated in the project template's description, some checkerboard hatch filling has been created. The odd and even fields are treated with different settings, and a small distance in between the fields is visible. It also has a special path sorting which can be visualized. All this toolpath properties are controlled by the JavaScript code in this project. Let's have a look at the content of the project. There are the JavaScript files. In this short video, we don't want to go into the details too much. Just keep in mind that main.js is the most important file in any ATU project. It contains the script functions which are called by Netfabb. Each function within the exports object can be called from outside the EBPA. So this is the interface of your EBPA. After watching this video, feel free to check out all the other project templates. There are several examples for different aspects of toolpath creation can be found. Now we are going to export the project to get an EBPA. Just enter a file name and press Save. Let's analyze this dialog. No passwords have been set. This means that anybody can use this EBPA, which would be locked by an execution password. And anybody can import the EBPA back into ATU and inspect the JavaScript code, which would be locked by a source access password. The version info shows that a daily build of ATU is used. This may cause issues if the EBPA is used with an official release of Netfabb. This is because the EBPA may use functionality which is not yet contained in the official release. Let's save it anyway. EBPA passwords can be specified in the project properties. Passwords entered here will be used for this project only. So individual passwords can be used for different projects. After changing the passwords, just save the EBPA again. Of course, the existing file can be overwritten, but we save it to another file this time. It is now confirmed that passwords are set. The password quality is not checked. It is up to the user to choose BIP passwords depending on how important the protection is. Now, back in Netfabb, the new EBPA can be imported. There is a menu entry in the context menu to import an EBPA. Pick the file which has no password. The password field can be left empty. The EBPA provides different options for material and layer thickness. Just pick one. Now see the parameters which have been defined by the ATU project. The default values here are the same as the defaults in ATU. If now the toolpath preview is recalculated, it can be seen that the checkerboard hatching style is applied. So you have learned what an EBPA is and how you can use custom EBPAs in Netfabb. And you know how EBPAs are created. Thanks for watching this video.